Looking to land a Rust job in 2025? The competition is fierce and interviewers want more than textbook answers. They're after your grasp of Rust's core pillars: ownership, lifetimes, error handling, smart pointers, and more. In this video, we'll break down the 8 essential Rust concepts that show up in almost every interview. Each section gives you a concise, confident answer you can use to stand out. Let's dive in and master what really matters. First up, ownership. Every value in Rust has a single owner. When that owner goes out of scope, Rust frees the memory. No garbage collector needed. Borrowing lets you access data without taking ownership. Many immutable references or one mutable reference at a time. The compiler enforces these rules, preventing data races and memory bugs before your code runs. Ownership, scope-based dropping, and strict borrowing together guarantee memory and thread safety. You're not just managing memory. You're proving to the compiler your code is correct. That's Rust's real power. Lifetimes ensure references are always valid, no dangling pointers. The compiler tracks how long references live, usually inferring lifetimes automatically. Sometimes you add explicit lifetime annotations to clarify relationships. Lifetimes, combined with ownership, let Rust guarantee memory safety at compile time. No garbage collector, no runtime cost. It's static analysis that delivers C++ speed with even stronger safety. Rust's error handling is explicit and robust, using and is for values that might be missing. No nulls, just or, is for operations that can succeed or fail, for success, for failure. The compiler forces you to handle every case, making your code safer by default. Use for clarity or the operator to propagate errors cleanly. Rust's approach means fewer surprises and more reliable code. Versus, a classic Rust interview question, owns heap-allocated, mutable text. When it goes out of scope, memory is freed, is a lightweight borrowed reference to UTF-8 text, immutable and efficient to pass around. Use when you need ownership or to modify text. Use for flexible read-only access. Knowing when to use each shows you understand Rust's memory model. Smart pointers are key and give single ownership of heap data. Great for recursive types or large values. Enables multiple owners in a single thread via reference counting. Is like but thread safe for sharing across threads. Use for single ownership, for shared single-threaded ownership, and for shared multi-threaded ownership. For mutation, wrap with for or for. Pick the right smart pointer for the job. Zero-cost abstractions mean you get high-level code with no runtime penalty. Rust's compiler turns features like generics, traits, and iterators into efficient machine code. No extra allocations, no slowdowns. Iterator chains, for example, become a single optimized loop. Traits and generics are resolved at compile time, so you only pay for what you use. Rust lets you write safe, expressive code without sacrificing performance. Rust enables efficient, scalable concurrency. Functions return, values representing work that isn't done yet. Pauses the task, letting other work run without blocking threads. Executors like Tokyo run millions of tasks on a few threads, thanks to Rust's lightweight state machines. In interviews, explain how Rust's Async model delivers high performance for I/O-bound apps. Rust guarantees thread safety at compile time using and traits. Types can be moved between threads. Types can be shared across threads. The compiler blocks unsafe sharing. Isn't. For shared ownership, use. For shared mutation, wrap with or. The type system ensures you lock data before access and release locks safely. This eliminates data races by design. Rust's fearless concurrency is real. That's it. Ownership, lifetimes, error handling, strings. Smart pointers, zero-cost abstractions, async, await, and thread safety. Mastering these isn't just for interviews. It's how you write safe, modern Rust. Show you understand not just what, but why memory safety performance and robust concurrency. Draw connections between concepts. Ownership enables safety. Lifetimes prove validity, traits and types enforce correctness. Practice explaining these ideas and use real examples. Name drop crates like Tokyo and Surdy for bonus points. Nail these concepts and you'll stand out in any 2025 Rust interview. For a deeper dive, check the blog in the description.